So let's solve the other set of question. So the problem 6 is find the occurrence of an integer in array. So in a given array, you have to find the occurrence of each element. For example, 10 is occurring 1, 2, 3 times. So your output should have a value 10 and occurring 3 times. Same way for the other elements. So now how can you do this? You can do this with the help of map. So you create a map, basically a dictionary, and iterate your elements in an array. If this element, so we'll use this as a key. So if arr of I, array of I is there in map of keys, then we'll increase map of array of I plus 1, will increment it. Else we will, if it is not occurred before, we'll set it to 1. Finally we will loop through the map and will display the key and value. Okay, this is how we can do this in O of n time. Next question is to find the first and last occurrence of an integer in a sorted array. So in a sorted array, you would be given a value k, for example 5. You want to find the first occurrence of 5 and last occurrence of 5. So from this question we know that we are given sorted order. So whenever a sorted is there, we can try something like binary search. Now in this case what we can do is we can modify the binary search such that first, for example, we have an array, and in the array we will find the midpoint, and we will try in one function will write one function where it finds the occurrence of that element in the left side, and another function that will uh, trying to find the occurrence in the right side. Even if it finds, it will keep on going until it reaches the end. So what we can do is we can create a binary search. We find we write a method called search first. We pass the array and what is the target element that is needs to be found, and the size. So first we'll find the, again like typical binary search, we'll set what is the low, what is the high, and here we are setting the result initially -1. Then we will try to find the mid until low is less than or equal to high, and if we found the mid, for example here is the mid and mid is equal to the target. Now in search first method our goal is to find the occurrence in the left side. So we will try to change high equal to mid -1. If that number is not equal to mid, if num of mid is greater than the target, then if this is greater, then it will be present in the left side again. Then I will change high to mid -1 or the other. Okay, now in the search last our goal is to move towards the right. So when the target is found, when the number array of mid is equal to target, we'll set the position of it, but we will try to change the low value to mid +1 and again search that element in this side. This way we can get the first and last occurrence of the element. Next question is sort the array of zeros, ones and twos. So given an array which is having elements which can be only 0, 1 or 2 in any order, your goal is to sort them such that 0 occurs first, then 1 and then 2. Simple solution would be to do a sort, which will take n log n time. Brute force, another method you can do is you can iterate, count the occurrence of 0, occurrence of 1, count the occurrence of 2, then again run through this loop and set the value, set all the initial value with 0s, 1s and 2s like this. It will take 2 of n time. There is an algorithm called Dutch algo wherein they have a method algorithm to do this solve this problem. So basically what you will do is you will take 3 pointers, low, mid and high. The low and mid will point to 0 and high will point to the last index, that is length of array -1. then you will iterate till mid is less than or equal to high. Then if array of mid is equal to 0, you will swap array of mid with array of low and increment both low and high value. If array of mid is equal to 1, you will increment mid. If array of mid is equal to 2, you will swap high and mid and decrement high. So this algorithm will solve this problem. So this is how the code looks for this. This will be done in O of n time. The next problem is given a subarray with given sum. So you will be given a subarray and a k value for 2. You want to find the number of subarrays in this array that can give a sum of 2. So over here k value is 2. So if you take first two element, we'll get a sum of 2. If we take the last two element, we can get the 2. But we can't take the first and last because subarray is continuous. For example, if we have array 1, 2, 3, this 1 is a subarray, 2 is a subarray, 3 is a subarray, 1, 2 is a subarray, 2, 3 is a subarray, or 1, 2, 3 is a subarray, but 1, 3 is not a subarray. So how to solve this problem? This problem can be solved using prefix sum. So basically, if we assume this is our integers, our elements in the list, and we will try to maintain a prefix sum. And so basically, initially we have 0, sum is 0, and number of times the 0 sum occurred is 1. So this will be maintained in a hash or map, you can say map. And so 3 sum occurs once, so setting 1. 9, 3 plus 9 is 12. Then we will try to 12 minus, our goal is to find all the subarrays which leads into sum of 5. So here 3 plus 9 is 12. Then we will subtract 5 from 12 to see if there is any number that occurs 7. So why we are doing is because if we look at the example here, let's say here 15, till here if we add 3, 9, minus 2, 4, 1, you will get some 15. Now when I do 15 minus 5, I get 10. So we'll look here 10 occurred, right? So till here sum is 10 and here it is 15. So from here to here itself we are getting the sum of 5. Okay, same way here, till here sum is 8, we subtract 5 from 8, we get 3. Is there any 3 occurring? Here 3 occurring. So from here 3 till here it is occurring 3, and till here it is occurring 8, means in this gap there is a 5. If we add this, we'll get a 5. So what in the code, what we are gonna do is we will iterate to this. Initially we'll have a map, we will have a prefix sum of 0 with the occurrence 1. Now here prefix sum is 3. We'll go on adding. First, after adding, we will check whether prefix sum, that is 12 minus the prefix sum minus k, is there in our map or not. If it is not there, we'll add this element in the map with 1. Okay, so what we're doing, let's look into the code. So initially the result is 0, prefix sum is 0, and we have a map with 0 occurring once. Now we'll loop through the array and initially we'll calculate prefix sum. Prefix sum is nothing but prefix sum plus num. Now we check whether prefix sum minus k, prefix sum, so here prefix sum is 15, 15 minus 5 is 10. Now we check whether prefix minus k is there in our map. So 10 is there or not? Yes, 10 is there. if it is 10 is there, then our result is equal to, already we would have find some subarray, so result plus how much time it occurred, 1 time it occurred. Okay, so 1 time. Now now we will check if prefix sum is not. What happens if prefix sum? Now first we found prefix sum, then we check whether prefix sum minus k is there or not. Then if now we will check whether prefix sum itself is there or not. If prefix sum is not there, we will set it to 1. If it is there, we will increment map of prefix sum plus 1. So this is how we will code it. Next, the final problem that we will look is to move all the negative element to one side and positive element to one side. So let's say we have an array and our goal is to place all the positive element to the left side and negative element to the right side, and also maintain the order. So what we can do is we'll iterate the array. If positive is found, we'll place in the I counter which starts from 0. So we'll set I to the initial counter and j to the last element, last index. Whenever a positive element is found, we'll place in I index and increment I. Whenever negative is placed, we'll place I, that negative value, into jth index, decrement j, and this will go on. Finally we'll have I in one end and j here. Now since we need to maintain the order, so the order of negative elements is reversed. So what we'll do, we will just reverse this. So we are writing a for loop. If it is a positive element, we are placing into the ith index, incrementing I. If it is negative element, we are placing into jth value and decrementing jth index and decrementing the j value. Now finally I will be pointing to the first negative element here, and we should go till the last element, and we will swap from the last element till I minus 1. Since it will not be considered, we will take I minus 1, then we have to decrement, so we give minus 1. So this will reverse the negative part, and finally we will get the correct array. So this is how these were the problems that we solved today, and now we will look the other question in the next session. Thank you.